Lesson 08. Draw scatter plots and best fitting lines. A scatter plot is a graph of many data points. Kind of like that. A positive correlation, we say the scatter plot has positive correlation if the slope of the scatter plot tends to be positive, like that. It would have a negative correlation if the slope of the points appears to be negative. It has no correlation if there's no obvious pattern from the scatter plot. We can measure how well a scatter plot fits a line by using the correlation coefficient, which is a number between -1 and 1 that measures how well the data fits a line. Positive for positive correlation, negative for negative correlation, and r equals 0 means there's no correlation. So -1 means perfect line with a negative slope. 1 means perfect line with a positive slope. So some examples. For each scatter plot, tell whether the data has a positive correlation, negative correlation, or no correlation, then tell how well what the correlation coefficient is. Well, look at this one. You can see there tends to be a general upward trend, so it's positive. It's not a great fit to the line, but it's obviously somewhat of a positive trend, so we'd say that one is positive because it's going up, and about 0.5. 1 would be a perfect line. All right, this one you can see there's a trend downwards. So since it's downwards, that's a negative slope. So it's a negative correlation. And it fits that line really closely, so we'd say it's about -1. This one doesn't seem to have any particular pattern, doesn't seem to really fit any line whatsoever. So we'd say this is approximately no correlation. So R would be about 0. Well, if some of the points, some of the graphs fit a line, it'd be nice to know what that line is. So to find the best fitting line, the best fitting line would be a line that most closely approximates the data. And to find it, you're going to draw the scatter plot of the data very nice and neatly, very, very carefully. You're going to sketch the line that appears to follow the data the closest. And when you do that, there should be, the line needs to go through the middle of the points, of the group of points, not at the top, not at the bottom. So if you have a bunch of points like that, you have to go through the middle. Choose 2 points on the line and find the equation of the line. Now it could be a point, one of the data points on the line, but maybe it's just where the grid crosses and you can use that point. They don't have to be original data points. What they should be is they should be far apart when you choose those 2 points. Don't pick them right next to each other. Make sure they're far apart. Make sure you pick them from the graph, and they're points that are actually on the best fitting line that you drew on the graph. Don't just pick 2 random data points. For example, monarch butterflies. The table shows the area in Mexico used by monarch butterflies to spend the winter. Y in acres, X in years. After 2006, approximate the best fitting line for the data. All right, what we're going to have to do is we would have to draw a very careful graph. The x's are 0, 1, 2, 3. Of course, you'll want to do this on actual graph paper. And then the y's, I need to get up to like 17. So if I call that one 20, halfway down would be 10, 5, 15. So 16.5 would be there. 11.4 would be there. 12.5 would be there. 4.7, 9.9, 7.1, 2.9, well, that dropped a lot, and then 1.7, that dropped a lot there. But you can kind of see we have a general downward trend. And so you'd probably want to use a ruler to draw your best fitting line, maybe something like that. So I could use that point and that point. So now I have, so those are 2 points that my line happened to go through. Remember, you could also pick points that are not on the graph, just points that you can read from the graph because of the grid. Doing this on graph paper would help a lot. All right, you need to find your slope, which is y2 minus y1 over x2 minus x1. All right, so 16.5 minus 2.9. Oops, sorry, that's backwards. Is negative 13.6 divided by 6. It's about 2.6. Sorry, 2.267. And then we need a point. Since this is the y-intercept, that's the b, so it's y equals mx plus b. I know the slope, which is negative 2.267, x, and then b was 16.5. Guarantee that that was not the best answer. But that's our approximate. All right. Let's use that to predict the area used by the butterflies in 2016. Well, the X was the year since 2006, so 2016 would be 10 years. We're going to plug in a 10. Negative 2.267 times 10 plus 16.5. I get negative 6.17. Oh, wait, the area is negative? What's that mean? That means they're extinct. Wait, they're not. There's still butterflies around. Monarch butterflies. Just found one in my yard a couple days ago. Maybe, now I said this was just an estimate. Maybe we could use technology to get a better best fitting line. If you have a TI-84, here's how you could do that. Push your stat button, select edit. Enter the X values in list 1 and the Y values in list 2. And then that'll give you the points. To see the graph of the points, push the Y equals button. Clear any equations. And while you're still in the Y equals, go up and highlight plot 1s. It's at the very top. And this is plot 1. You want it highlighted, press enter so that you have plot 1, and then it'll say plot 2 and plot 3. You only want plot 1 highlighted. And then you're going to press zoom and zoom stat, and that'll zoom so you just see your points. Then push the stat button and go over to the calc menu. Select linear regression ax plus b. That's the same thing as mx plus b. And it'll ask you a bunch of questions. If you have a newer TI-84, if you have an old TI-83 or old TI-84, you won't get this. You'll just hit enter a couple times. But most of you will get this. And it'll be a little pop-up and it'll ask what the X list is. Well, your X list should be L1. The Y list should be L2. The frequency list is blank. Leave it that way. And for store regression equation, you want Y1. Get Y1 by pressing the variables button. Select Y variables. Select function. Select Y1. Press calculate. And it will give you the equation for the line. And to see your graph, just hit the graph button and it will show the graph. But what if you have a NumWorks graphing calculator? Oh, it's much easier actually. On the home screen, select regression. In the Data tab, enter your points. Move over to the Graph tab, and you'll see your points and the best fitting line. The default is a linear regression, which is what we're looking for. And its information is displayed at the bottom of the screen. You see the A, which is your slope, and the B, which is the y-intercept, and you also have the R for the correlation coefficient. If you want to change the regression type, let's say we're doing some sort of curve, you'd press OK, select regression and your other regression type, and it'll change that. But for today, we just want lines, so you don't need to do that for today.